proportions are so handy and you see them all the time. For example, if you've ever looked at a paper map, the scale of the map would have been somewhere on the paper that showed how long a distance was on the map compared to real life. And so a scale drawing shows a real object with accurate sizes, but they're reduced or enlarged by a certain amount, and that's called the scale. So here you can see in particular the definition of a scale is that it's a ratio. And this scale is written on whatever piece of paper that the drawing is done on. So here's an example with a blueprint when you have house plans or something like that. A blueprint, a room is 4 inches by 6 inches. Apparently my cat really wants to make this video for you because he keeps yelling. Back to our word problem. On a blueprint, a room is 4 inches by 6 inches. And so you can picture, maybe if you wanted to draw a picture, that the room is 4 inches in the width and maybe 6 inches in the length. And it wants to know the true dimensions of the room with the following scales. So on your map, you would see somewhere this 1 inch to 2 feet. And we'll use that information to help us set up our proportion. So we know 1 inch on the map is equivalent to 2 feet in real life. And so we want to know what that 4 inches on the map equates to in our real life room. So that would be our unknown variable x that we need to solve for. And then you cross multiply and you would get the fact that 1x equals 8. And then, so 8 is actually the length in feet, the width in feet of that part of the room. So then you would have to do another proportion. You'd have to say, for the other dimension, we would erase these, and now the 1 inch scale over 2 feet would be equivalent to 6 inches on the map over some value in real life. And when you cross multiply that, you're going to see that x equals 12 feet. So your real room is 8 foot by 12 foot, but on your scale drawing it would show up as 4 inches by 6 inches. Why don't you? So I'm going to have you try this next example, number 5, and they're just changing the scale on you. The room is still 4 inches by 6 inches, but now the scale on the map is 1 inch is equivalent to 6 feet. So you go ahead and find the new dimensions of the room according to the new scale. Pause the video. And here's how the work and the final answer for the real room is for this. So you have a room that is truly 24 feet by 36 feet. So here's an example of what a better blueprint might look like. You would unroll this and there's your blueprint of a great room, a hallway, and a den. And you can see down here in the bottom corner that you have your scale, that 1 inch is 12 feet. So 1 inch on this map is equivalent to 12 feet in real life. We'll do the hallway together, find those dimensions, and then I'll leave you to finish it up with the dimensions of the great room and the den. So once again, the scale you will be using is 1 inch, equivalent to 12 feet. And we will start with this length of the hallway first. We know that that's 15 inches on the map, and we want to know what that is in real life. When we cross multiply that, we will get, and our unit will be in feet when we're done, 180 feet when we cross multiply. And so that would be this dimension here, that this was truly a 180 foot long hallway. So then you would go and do it again, except now this would be 1 inch here. So I will erase this and replace it now with the 1 inch length hallway. I'm looking at this part here, so that'd be 1 inch over X, and you can see either by just looking at it or if you had to cross multiply, go for it, that this would also be a 12-foot width then for that hallway. So our dimensions of our hallway are 180 by, and we use that X for that, by 12 feet. And I'll use the little hash mark. So you go ahead and find the dimensions of the great room and then the dimensions of the den. And there we have all the dimensions. Okay, well thank you for watching this video, and my cat thanks you too.